Hello, algebra students. Mr. B here. All right, we're into the last video about graphing rational functions. And here's our rational function, x squared plus 4x minus 5 over x minus 3. If we factor this, you'll see that we get x plus 5 on the top times the quantity x minus 1. And then in the denominator, we still have x minus 3. That's fully factored. All right, step 1. Are there any common factors in the top and the bottom? And I don't see any. No common factors. And what does that mean? It means we don't have to limit the domain of the rational function. No common factors. All right, step 2. What are our x-intercepts? Our x-intercepts are the zeros of the numerator. And I hope we can see that that's going to be -5 and 1. And the multiplicity for both of them is 1, right? The power on these binomials is 1. When the multiplicity is 1, what happens to the graph near the x-intercept? It goes through the x-axis. Goes through x-axis for both of them. Okay, 3, the y-intercept. That's where x is 0, right? So we want the rational function at x equals 0. We can easily see from this standard form that the only thing that's going to remain if we put x equals 0 in here is -5 over -3. So negative over a negative is positive, so we get positive 5/3 for the y-intercept. All right, and then we have our vertical asymptotes. I'll abbreviate that, VA. They're the zeros of the denominator, and we see we only have one zero of the denominator. It's 3. X equals 3. The multiplicity is 1. It's odd, so the graph looks like 1 over x near the vertical asymptote. So it either looks like this, or if we flip around the x-axis, it looks like this. So either way, we aren't sure which one it is yet, but we'll find out. Okay, and then step 5. Step 5 has been horizontal asymptotes up to now, but I want us to see that here, n, the power of the numerator, the degree of the numerator, is 2. And the denominator degree, m, is 1. And so we say, n equals m plus 1. 2 equals 1 plus 1. That means that we have a slant asymptote. Slant. And spell asymptote right. Good to be able to spell it, right? Asymptote. All right. So what is the equation of the line that is the slant asymptote? To do that, we have to divide. We have to divide the denominator into the numerator. In this case, we could use synthetic division since the denominator has this x minus c form, right? So what are the coefficients of the numerator? 1, 4, and -5. 1, 4, -5, and the 0 was 3 for the denominator. Right, the c was 3. So what happens here? We get 1, and we multiply 3 times 1 is 3. Add, we get 7, and then multiply 3 times 7 is 21. Add this, we get 16. That's the remainder. We don't really care about the remainder. We just care about the quotient. This one represented x squared, so this one here represents x. So what we've shown is our rational function equals x plus 7 plus, if I write the remainder piece, it would be 16 over x minus 3. We don't really need that. This gives us the equation of that line. Y equals x plus 7. is the equation of the slant asymptote. Equation of slant line. All right. If we're really astute, we might ask, does the function cross the slant asymptote? That's where this actually is equal, where r of x equals x plus 7. So let's see if that happens. We set r of x, which is x squared plus 4x minus 5 over x minus 3. Where does that equal x plus 7? Well, to solve this, we would multiply both sides by x minus 3. Remember, when you solve a rational equation, you multiply both sides by the LCD, which is in this case x minus 3. And that'll leave us x squared plus 4x minus 5. And on the right side, x squared plus 4x minus 21. I'm foiling this in my head. I see that if I subtract x squared from both sides, that goes away. And in fact, if we subtract 4x from both sides, the 4x goes away. There's no more x. And we're ending up with negative 5 equals negative 21. That's a contradiction. Contradiction meaning there's no solution. And so the graph does not cross the slant asymptote. That's what that means. Graph doesn't cross the slant line, slant asymptote. Okay, let's graph. Let's graph this thing. We're going to need a little bit of room above because we have the slant line goes through 7, right? It was y equals x plus 7. So 1, 2, 3, 4, 5, 6, 7. The slope, this is in slope-intercept form, right? mx plus b. So m is 1, the slope is 1, and the intercept, y-intercept is 7. That's where I'm getting this from. So the slant asymptote has a positive slope, 45 degrees, 4, 5, 6, 7. It's going to go through negative 7 and 7. I should dash this line. I should dash this line. It's not the horizontal, but slant asymptote. Yeah, I'm getting a little sloppy there. Okay, good enough. Should I fix it a little bit? It's looking a little wonky, as we say. Okay, better. So where was our intercepts? Negative 5 and 1. Negative 5 is there. 1 is maybe here. And where was our y-intercept? 5/3. It's like 1 2/3. That's maybe about here. And then we had a vertical asymptote at, what, 3? 3. So 1, 2, 3. We'll draw a dash line, a vertical dash line there. Okay. Well, let's worry about this graph between the vertical asymptote and the slant line. I see that we have two x-intercepts and the y-intercept. And the behavior near this vertical asymptote is going to be either like that or like that. We don't know which, but I can guess that on the left side it's got to come up and go through the x-intercept, through the y-intercept, and then back down through the other x-intercept and get closer and closer to the slant asymptote and never cross it, right? We found out that it never crosses it. So I don't think the graph goes like this on the right, because our thumbnail said that its opposites, right? It's like 1 over x. So if it peels off to the left at the bottom, it has to peel off from the top to the right. And so up here, it's got to come down. And then what happens? It's got to come back up and get closer and closer to the slant asymptote line. Here's our y-axis here. All right, if we got everything, maybe we'll just label where our y-intercept is. If that was 5/3. Label the x-axis, maybe put a 3 by the vertical asymptote there. If I got all the other numbers, maybe put the -7 up at the top where we can see it more easily. What do you think? Are we done? Okay, that's it for graphing rational functions. We'll see you in the next video, whatever that's on.